Okay, we'll go ahead and get started. I'm trying a different way to record because the last few recordings have frozen on us. So I'm going to try to record using my laptop. I wanted to go over more from lessons 8, 10, and 11 today. Before I do that, off campus, can you hear me okay? Off campus, can you hear me okay? Let me try this. Hold on. Okay, if you want to type in the chat box, if you can hear and see me okay. That way I'll make sure. Off campus, can you hear and see me okay? You can hear me okay? Awesome. Thank you. And see. Okay, thank you so much, off campus, for confirming that. All right, we'll go ahead and get started. I'm recording now, and again, I want to try using my laptop and my whiteboard and record off of it, and hopefully this video will not freeze like the last couple ones did. I wanted to go over some more from lessons 8, 10, and 11, and nothing has changed. If you have a question, feel free to unmute your mic and chime in. Or if you want to use the chat box, it's available also. And I'll keep checking the chat box as we go along today. All right, this is a question from lesson 8 that I wanted to review the product rule with you guys. So let me write down the product rule first. The product rule is you take the derivative of f, or f prime, times g, whatever it is, plus f, whatever it is, times the derivative of g. And which, in this case, your x squared is your f of x, and e to the x power is your g of x. So let's plug everything into our product rule. I forgot to check on campus. Can you see the screen all right? Okay, cool. The derivative of f, or derivative of x squared, times g, or just e to the x power, plus f, or just x squared, times the derivative of e to the x. Now, using the power rule, the derivative of x squared is just 2x. And bring over the e to the x power. And x squared, bring that down also. And the derivative of e to the x is still e to the x power. So this is our final first derivative. I'll leave this up here if you're still jotting it down or taking a picture of it. Are there any questions about this first problem? All right, let's look at a quotient rule problem that also involves trig functions. So let me clear our board and we will look at the next problem. We have h of x equal to x all over 1 plus sine of x. Now, because we have a fraction, we must use the quotient rule. So the quotient rule is still a fraction. The derivative of f times g minus f times the derivative of g, and that's all over your denominator quantity squared, in which f of x is your x and g of x is your denominator. So let's plug everything into our quotient rule. Over here, the derivative of f, or derivative of x, times g, which is 1 plus sine x, minus f, which is x, times the derivative of g, or derivative of 1 plus sine x, and that's all over 1 plus sine x quantity squared. I forgot to ask Mr. Leon, can you hear and see everything okay?
Yes, sir.
Okay, thank you. All right, the derivative of x is just 1 times 1 plus sine x minus x. Over here, the derivative of 1 is 0. That's a constant. And the derivative of sine x is cosine x. So what we're left with for the second half of our answer is x times cosine x all over our denominator squared. And you can actually erase that first one because it's understood to be there. So our final answer is actually 1 plus sine x minus x times cosine x all over 1 plus sine x quantity squared. Before we look at our next problem, are there any questions about quotient rule?
Sir.
All right, let's look at another question involving trig identities, or trig functions, I should say. we have y equal to sine x plus cosine x, and that's all in parentheses, and it's being multiplied on the outside by secant x. Now, before you use the product rule, just multiply or distribute by the secant x. So we have sine of x times secant x plus cosine x times secant x. Now we know that secant x is the same thing as 1 over cosine. So let's make that substitution for each secant. Now for the second part of our problem, the cosines cancel out, and that leaves us with just 1. Sine over cosine is tangent x. Now we're ready to take our first derivative. So y prime is equal to the derivative of tangent x is secant squared x, and the derivative of positive 1 is 0. So our first derivative is actually just secant squared x. Any questions about this particular problem? And also feel free, as I mentioned, WebEx has a chat feature, so you can certainly type your questions in the chat box if you want to, or you can unmute your mic as y'all been doing and ask your question. All right, let's look at another problem. Going back to base E. Now, before we look at an example, anytime your exponent is something other than x, let's say u, for example, then to take the derivative of e to the u, it's still e to the u power times the derivative of whatever your exponent is. So this is the main property that we're going to be using to figure out our next problem.
What is this property called again?
Oh, it's a derivative of e to the u.
Okay.
And you have to do like a little substitution. Whatever u is, it's kind of like the chain rule. You just bring down what you're given and then take the derivative of your exponent.
All right, makes sense.
Now let's look at this problem. We need to find the derivative of y equal to e to the negative 7x power. So when we take the first derivative, and remember, if we're taking the derivative of y with respect to x, that can also be denoted by this ratio. So y prime is the same notation as dy over dx. So using our e to the u property, we bring down what we're given, e to the negative 7x, and we just simply take the derivative of our exponent, negative 7x. All right, the derivative of negative 7x is just negative 7. So our final answer, moving the negative 7 to the front of the e, is negative 7 e to the negative 7x power. Any questions before we look at a natural log problem?
Yes, sir. You kind of lost me after you said that the derivative y over derivative x is synonymous with y prime. So do you mind explaining that again?
Sure, not at all. If you're taking the first derivative, there are several ways to make that notation. You can use the tick mark here to denote that you're taking y, the derivative of y, the first derivative of y. Now, because we have y and we have x, we're actually taking the derivative of y with respect to x. In other words, it's still kind of like trying to figure out the change in y with respect to the change in x. So change means derivative. So it's just a notation. Anytime you see the derivative of y over the derivative of x, you're still just really taking the first derivative of your problem.
Okay. And the formula that you have boxed out, that's what you use to solve this, right?
Yes, sir.
Um, and instead of just having y prime, I mean, instead of having the derivative over derivative x, you just had y prime.
Yes, sir.
Okay. All right.
Yeah, they just mean the same thing. You might, my math lab may ask you to find dy dx. That's the same thing as finding the first derivative.
Okay. And you cancel your x's out from the x in parentheses and the x that's in the exponent, right?
Oh, no, sir. Actually, we took the derivative of our exponent.
Okay.
So the derivative of negative 7x is just negative 7.
Right. Okay. All right. I see the pattern.
Okay. Let's look at one involving a natural log. And I want to go over its first derivative property with you as well. To find the derivative of natural log or ln of x is just simply 1 over x. If all you're given is just x, okay? Now, if you have the derivative, if you have natural log of u, in which u can be anything else besides x. So if you have anything else besides x, then It's still 1 over your function, whatever it may be, 1 over u. And then like we did with the e to the u part, we take the derivative of whatever our u is. So it still follows the pattern. It's 1 over u, whatever u is in your natural log function, times the derivative of u. Let's look at a few examples using this second property. We need to find the first derivative of the function y equal to natural log of in parentheses 2x. Now we use our second property that I just boxed in. Our first derivative, or y prime. When you take the derivative of natural log of whatever your function is, you automatically put 1 over your given function, and then take the derivative of your given function. So for this problem, we're taking the derivative of 2x. Now the derivative of 2x, I'm just moving everything over here. The derivative of 2x is equal to just 2. Now in this particular example, there are some things you can cancel out, namely the 2's. So the 2's cancel out, and our final first derivative is just 1 over x. So let me just walk you through the rule that we used here. Anytime you got natural log of something besides x, you automatically put 1 over that something, whatever it is. In this case, it was 2x. And then you take the derivative of that particular something. Again, we just took the derivative of 2x here. Are there any questions before we look at another example involving logarithms?
No, sir.
Okay. Any questions here on campus? All right, let's look at another function involving natural log. And I'll leave our derivative rule up here. Next problem, we're finding the first derivative of y equal to natural log in parentheses 3x squared plus 1. According to our second rule, you automatically put the 3x squared plus 1 underneath 1. And this is, you can think of this as a partly chain rule times the derivative of your function. So we'll take the derivative of 3x squared plus 1. Now over to the side, when we take the derivative of 3x squared, that gives us 6x. And the derivative of positive 1, that's just 0. Now, in this example, there's nothing we can cancel, although it looks like the 3x squared and the 6x can be simplified. We can't do any simplification here because that 3x squared plus 1 is an expression. So we can't break it up and cancel just part of it. So our final answer is still as a fraction. 1 times 6x will give us 6x all over 3x squared plus 1. Any questions either off campus or on campus?
No, sir.
Okay. I want to revisit the chain rule and go over some questions that you'll definitely see in my math lab homework. Something like this. We have our y equal to 9u, u is in unique, plus 1. And we're also given u is equal to, this is a fraction in parentheses, 1/3 times x to the 4th power. And I'll go ahead and tell you in my math lab will ask you to find dy over dx. This is one of the few times that the view an example help tool does not help out at all. I'm going to show you a very simple way of doing this. Where you see the u, replace it with the 1/3 x to the 4th power. We have not taken the derivative yet. Before we take the first derivative, we can simplify the 3 and the 9. That will go 3 times, which leaves us with 3x to the 4th plus 1. Now we are ready to find the first derivative, or dy dx. So dy dx, on the right-hand side, define the first derivative of 3x to the 4th power. Just use the power rule. So that will give us 12x cubed. And the derivative of 1 is 0. So dy over dx is equal to 12x cubed. Are there any questions before we look at a similar problem involving u?
No, sir.
Okay. This next example also involves u, but also includes a trig function. So our next question is y equal to, sorry for the delay, I lost my problem. Y equal to tangent of u where u is equal to 7x minus 5. And we're still looking for dy over dx, or the first derivative. Well, all you have to do before you find the first derivative is everywhere you see this u, replace it with 7x minus 5. And that gives us y equal to tangent, in parentheses, 7x minus 5. Now we're ready to find the first derivative, or dy over dx. So the derivative of y with respect to x. And we have to take the derivative of tangent first. So the derivative of tangent is secant squared. Now hold off. Don't take your derivative of your 7x minus 5 just yet. Bring that down. And we're going to use the chain rule to finish our derivative. So the chain rule, we times, and we take the derivative of 7x minus 5. The derivative of negative 5, because negative 5 is a constant, its derivative is 0. And the derivative of 7x is just 7. Once we move the 7 in front of our secant squared, our final answer is 7 times secant squared of, in parentheses, 7x minus 5.
I have a question.
Yes.
Way back there, why did you use secant squared instead of tangent?
Oh, you had to take the derivative of tangent.
Oh, okay.
Right, and the first derivative of tangent is secant squared.
Okay. Why isn't it cotangent? I feel like this is a dumb question, but why isn't it cotangent?
Oh, it's not a dumb question at all. I'm glad you asked. Uh, the reciprocal identity of tangent is cotangent.
Oh,
Right. These are just, if you'll go back on Google and print out, just look for derivatives of trig functions. Look for a PDF, a website that offers a PDF file, and just print out the derivatives of your basic trig functions.
okay. Thank you.
You're welcome. Are there any other questions, either off campus or on?
No.
Okay. Let's go back and look at a few problems involving the chain rule, as well as some other rules kind of sprinkled in. So this first one, we have h of x equal to 7x over 1 plus cosine x, and all of this is squared. And we need to find the first derivative, or h prime of x. This involves not only the chain rule, but power rule and eventually quotient rule. We use the power rule first. So we will move our original exponent to the front of our fraction. Bring down our original fraction. And you still subtract 1 from the original exponent. So that's just to the first power. And this is the chain part of the chain rule times the derivative of our fraction. Now, in order to find the derivative of our fraction, we must use the quotient rule. Excuse me. So the quotient rule is the derivative of f times g minus f times the derivative of g all over g squared. In which, going back to our fraction, 7x is our f of x, and our denominator is our g of x. Is everybody with me so far?
Yes, sir.
Okay. Now let's fill in everything into our quotient rule. The derivative of f, or derivative of 7x, times g of x, or 1 plus cosine x, minus f, or just 7x, times the derivative of 1 plus cosine x, or g, and that is all over g squared, or 1 plus cosine x quantity squared. Now let's come back over here and take our derivatives. The derivative of 7x is just 7. The derivative of 1 is 0, as we know. And the derivative of cosine x, be careful, it's actually a negative sine x from our derivatives that we found off the internet. All right, so let's put everything together. 2 times 7x, we can go ahead and make that 14x. All over 1 plus cosine x. And let's bring all of this over. Let's see, times 7 times 1 plus cosine x. Let's see, a negative 7 times understood to be a negative 1 gives you a positive 1, a positive 7x sine x. And that's all over 1 plus cosine x quantity squared. Now, probably one last thing you could do, I don't mind that you leave everything in the numerator factored out, but if you wanted to combine the 1 plus cosine x's and just make that 1 plus cosine x cubed, I I would accept either answer. If you left it separate like this, that's fine. I'm gonna stop here, make sure, because there was a lot going on in this one problem. Did anybody have any questions or need me to go back over this?
Can you please go back over it?
Okay, absolutely. Okay. Give me 1 second to erase most of it. Okay, I will ask you guys, is everybody okay with this first step? Just using the power rule and setting up the chain rule. Did everybody get that part?
Yes.
Okay. I'm going to make a brand new page. Let's see if I can do this. Hold on just a second, y'all. I'm just going to make a brand new page and share it with you guys. Hold on just a minute. Okay, so I've just devoted one page to just taking the derivative of our fraction. Now we have to use the quotient rule. So our quotient rule, let's jot it down. It's the derivative of f times g minus f times the derivative of g, and that's all over g squared. We need to label our f and g before we plug everything into our quotient rule. F is our numerator, and g is the entire denominator. So let's plug everything into our quotient rule. The derivative of f means we're taking the derivative of 7x times g, or just 1 plus cosine x, minus f, or just 7x, times the derivative of g, or you're taking the derivative of 1 plus cosine x. And that's all over your denominator quantity squared. Or in other words, 1 plus cosine x quantity squared. Now we are ready to take the first derivative. The derivative of 7x is just 7. And over here at the end, the derivative of 1 is 0. And one of our derivative rules is the derivative of cosine x is negative sine x. All right, so we're ready to put everything together. We have 7 times in parentheses 1 plus cosine x. Over here, this is understood to be a -1 in front of that sine x. So when we multiply -1 by that -7, that gives us the positive 7x sine x all over our denominator squared.
So the derivative of cosine is sine?
Negative sign. Oops,
Negative
sorry.
sine.
Forgot my negative there. Yes, sir, is. Derivative of cosine is negative sine. Now, whatever we did at the very beginning with just the power rule, we're just going to bring that, transfer that over. So if I recall, it was 2 times 7x all over 1 plus cosine x. And as far as I'm concerned, because there was you had to do a lot of steps, you can leave your derivative like this. You don't have to combine anything together. Did it make much more sense this second time around?
Yes.
Okay. I'm sorry. Probably what added to the confusion is everything was kind of crowded on one page. Did y'all have any questions about this kind of review for lesson 8, 10, and 11?
No, sir. I don't have any questions at the moment, but if I do, can we just email you?
Sure. Yes, I check my email religiously several times a day. So, yeah, feel free to email me. Also, you can use that Ask My Instructor help feature that comes with most questions.
Hmm.
And usually, I'll just sit down at my laptop and create a quick video explaining whatever you're having trouble with.
Okay, that's great. Thank you.
You're welcome. All right, I'm gonna go ahead and end today's. Let's see, hold on. Before I speak too soon, let's see.